So Kyle is with ImageXpert. He's the Director of Applications Engineering, and he'll be telling us about print quality, all that can go wrong, and how to identify them. And yeah, and inkjet printing is kind of an art, so he'll tell us about how to get it right. So nice to have you on the stage, Kyle.
Thank you very much. Good to be here. Hi, everyone. My name's Kyle Pucci. I'm the Director of Applications Engineering here at ImageXpert, a company located near Boston, Massachusetts in the US. And today I'm going to be talking about print quality when it comes to printed electronics. I'll identify some of the things that can go wrong, or what are the most common things that go wrong when it comes to print quality in printed electronics. And then what are some of the tools that can be used to identify those things. So let's dive right in. Before I get into the details, I wanted to start with the big picture of what exactly is print quality. So if you take a look at whatever you're producing using this process, whether it's an image, whether it's a sensor, whether it's simply just a layer, print quality is grading the output of that process by analyzing it with numbers. So if you're printing traces, it might be analyzing the width or the quality of that trace. The same is true for an image. What's nice about doing print quality analysis is it's evaluating what you're producing right at the end of the line. So all of the different variables that go into play, whether it's the formulation of the material that you're printing, whether it's the substrate, the speed, the height, all of these things, print quality is kind of a final check to grade the output of all of those things working together. The other thing that's really nice about it is the numbers don't lie. So there's no subjective measurements that might vary from one location or one machine to the next. You can use this to compare different machines, even within your product line, or against kind of benchmarking other equipment in the field. You can compare the results of your prints in different environments, such as, a cold, dry region versus a hot, humid region. And then you can also use this for kind of quality assurance over time, where you can study the aging of ink or the wear on the print heads or the dispensers. So print quality is a really good thing to implement in your process to really make sure that you're driving improvements as best that you can. Print quality isn't typically measured on just anything. Often there are test patterns that you use where you would print a sample of this, and then that pattern is set up to be very easy to measure the performance of the certain features that you're most interested in. So on the left, you can see an example of what a pattern might look like. And in some cases, you're able to kind of analyze this either using a microscope or by eye. And some of those times you're able to get numbers. But on really robust setups, you actually can automatically detect the features as well as automatically capture the measurements that are most interesting to you. And that's really, that process is what we're talking about when we talk about print quality. When it comes to printed electronics, there's a kind of a wide range of applications that might come into play. We could be talking about flexible displays, could be talking about solar cells, could be talking about fabrication of sensors or circuit boards. So if we look at the whole broad spectrum of what printed electronics means, we see a couple of common patterns when it comes to what is most important when it comes to print quality. And those are the ones that are shown here. And we'll dive into each of those in a little bit more detail. The first one on the list is line width and continuity. If you're printing sensors, traces, circuits, whatever it might be, this is very important to you. This can be done on either a large scale, kind of like what you're seeing here, where you can look at an entire sensor and automatically detect if all of the traces were produced correctly as well as continuous. And when we're doing it on a large scale, you can see at the bottom here an example